everyone, I'm Ann Wizauer from HL7 headquarters, and I'm pleased to welcome you to this session from CDA to FHIR responding to COVID-19. Now I'm happy to turn it over to our speaker, Doug Seven.
Thank you, Ann. Hopefully we're going to see everything switch over to my screen now. Give me a quick yay. I'll take that as a yay. All right, everybody. Welcome to the session. As Ann mentioned, I'm Doug Seven. I'm Senior Director at Microsoft in our Health and Life Sciences group, specifically in our Cloud and Data team. We are the team that has been building the FHIR service and been active here in FHIR DevDays for a number of years. And many of you may have run into me at various FHIR DevDays events when we were all in person, which I sorely miss out on today. I want to use this time to talk about an interesting story from the last, a little over a year actually, about how we were able to partner with a Department of Public Health in a major US city in response to the COVID-19 pandemic. And in this case, the challenge was really around capturing CDA formatted data coming from hospitals and converting that data into FHIR format to be usable in actively reporting to the CDC and also actively tracking things that were happening with COVID-19. So I'm gonna go back in time and kind of tell the story of how we proceeded through this and show you some of the tools we used and some of the things we did to help solve this problem. Ultimately, this problem was solved sort of in a collaboration between a Department of Public Health in a major US city and an academic medical institution in that city as well, with support from us and our team. So it's really the story of what they did with the technology and how they applied it to an active and growing problem that was happening. And I'll make sure that we have about 15 or 20 minutes. I'll make sure I reserve some time at the end for questions. So please hold on to your questions. Feel free to put them in the chat as we get to the end of the session. Ann can relay the questions to me and we can address them. But let's get through the story first, because maybe some of your questions will be answered along the way. So let me start by going back in time a little bit. We're going to go back just over a year to April 13th, 2020. Certainly the pandemic had already started. Things were growing, particularly in the US. This is where this particular story begins. In this case, the Department of Public Health in a major US city, one of the top cities in the country, was working with local hospitals to gather critical data about confirmed cases of COVID-19. And they needed to collect this data and report it to the CDC, but also use it for their own real-time efforts to sort of quell the pandemic, if you will. On this day, there had already been over 20,000 confirmed COVID-19 cases in the county that this city was in. There was already more than 1,000 confirmed cases daily and growing in that county alone. And they'd already experienced pretty close to 800 fatalities. And it was like high 790 some odd fatalities on that day. So things were serious, and the Department of Public Health in that city was really looking for a way to respond in as near real time as they could to what was going on. So what was the proposal? How did this all start? That's the current situation. That's what was happening. So how this started for us is we were diligently working away on our FHIR service. We were diligently working away on different tools around FHIR. And we were working with lots of customers who were in the space of dealing with COVID in different ways. And in this case, we've been working with one of the medical institutions in the city. And in response to some conversations we were having, we got this email that said, hey, we need help doing something. We'd like to partner with you on it. We need to stand up an endpoint for accepting CDA documents. And we need to be able to convert that into something that we can use to report in near real time to the CDC about what's happening with the pandemic. And we want to make all of that data available as FHIR resources for interoperability purposes. So if we could do all of that in one activity, that would be great. That was sort of the goal. So that was the proposal. Hey, how can we help? What can we do? Where can we do? So our response to this was to jump in and say, okay, let's figure this out. What do we have currently and how can we help solve the problem? So let's dissect the problem a little bit. What's really happening in the city? What are they going through? What are they dealing with? What do they have to solve for? So there's a few problems. One is they have labs that are processing data to determine if a patient is COVID positive or not. And those labs are being asked to self-report their data to the Department of Public Health, but they don't really have a way of doing it. There's no easy mechanism for these labs to report that data to the Department of Public Health. Additionally, all of the emergency departments can output CCD documents from their EHR. So when they have a patient come in and they're presumed COVID positive or even confirmed COVID positive, they can output a CCD from their EHR. They need to then get that to the Department of Public Health to do something with that. All of this data needs to be aggregated from all around the city, from all the emergency departments and all the labs all around the city. And then it ultimately need to convert this all into FHIR data. This should be one large data set represented as FHIR data and accessible and available to both report to the CDC, but also do analysis on to figure out various things related to how to respond to the COVID pandemic. And so here's how we started to approach this problem. And here's what we did. And I'll kind of walk through some of the tools we used and what this ultimately meant for us and for how we used FHIR. The first thing is there was a number of cases where the Department of Public Health would receive direct messages of data, and that data needed to be converted into FHIR resources. They also were wanting to create a Power App that they could distribute to the labs that would enable them to do self-reporting on their COVID tests, where they were positive tests, where they were negative tests, how many tests they did, all those things. Then we needed to collect and convert the CCDA documents, the CCD documents from the EHRs coming out of the EHRs and the emergency departments into FHIR bundles and FHIR resources, and then develop views of that FHIR data to help in the reporting of the CDC. So how do we start approaching this? And why was this relevant at the time for us? Well, one of the things that was happening is the partner that had reached out to us and said, hey, can you help, had actually been working with us already on an open source project that we were working on called the FHIR Converter. Some of you may be familiar with this. This is an open source project. It's out on GitHub. And it consists of a few things. So the FHIR Converter is a project for converting non-FHIR PHI into FHIR data. So it has APIs for converting data. So you pass it in an HL7v2 message and you get back out a FHIR bundle, for example. It has a set of templates, and at this point in time, April 2020, we only had templates for HL7v2 messages. And so the request coming from our partner was, hey, can we do with CDA what you've already done with HL7v2? So that was an interesting proposition. We had some sample data for testing purposes. We, interestingly enough, for the purposes of experimenting and exploring, we have a browser-based editor that allows you to modify, create, and test these templates. And we now, since then, have also released a Visual Studio Code extension for doing the same thing. And there's a management API for managing these templates. The reason why this is important is this was the foundation for the request to say, hey, you're already doing something in this open source project to convert HL7v2 data to FHIR. Can we do the same thing for CDA? Well, let me show you how this tool kind of works. So I'm going to use the browser. I'm going to show you the browser-based editor to show you how this works. Oh, I think my slide's stuck. There we go. So this is just the browser-based editor with an HL7v2 message. So at the top of the screen, what you see is an HL7v2, in this case, an ADT message. At the bottom left, what you see is the template that we have. So we have these pre-canned templates that say, okay, if you want to transform an ADT message into a FHIR bundle, here's a template for that. In this case, you can see that this template is made up of sub-templates like patient, encounter, location. And then on the lower right-hand side, you see the resulting FHIR message. So here you can see, I've scrolled down and you can see a condition that was in the message here. if so the goal then was to say, okay, can we do this same thing for CDA? It's a different look, it's a different structure, but can we essentially use this engine, create a different set of templates that do the same thing and same processing? So that was the path we went on. And so what you see here is the CDA version of the same browser-based interface, where you have a CDA document in this case, a CCD document on the left, the template for doing the conversion in the middle, and the resulting FHIR bundle on the right. And of course, the middle is a bunch of sub-templates that we would use. So for example, if we want to look into one of these and look at how this works, I'm going to look at the vital signs sub-template, and we'll look at where that matches up in the CDA, the CCD document, and the resulting FHIR bundle as well. So if we dig into that, I've used some color coding to show you how some of these things match up. So you can see that in the template, we search for things that we would expect to find in the CCD document. So in this case, we're looking for this template ID with the root ID of 2.16.840, blah, 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 which results to vital signs. So that's the template for vital signs. And then you can see in purple, what we're doing is we're creating an observation in the FHIR bundle from this. And then we're capturing the information from the vital signs. And I didn't capture it all here, but you can see some of it. But what's interesting is we do a few things. So on the right-hand side in the light blue, you can see that we've shown the code from the code that's in there for the lung code, the systolic blood pressure. And just below that, you can see the effective time and the quantity of 120. That's actually in the CCD document, just a little below the scroll that I have here. So it's a little out of view, but you can see how those codes translate through. But also you'll notice that the time, which is highlighted in green, was transformed from its normal format in CCD to the format that would be expected in FHIR. So we do some sort of intelligence on the data as well to say, okay, well, not only are we just going to copy and paste data into a different format, but we're going to apply some intelligence to it to make sure we adhere to the standard, in this case, FHIR, and what we're doing with code systems and things like that. So these templates are designed just to sort of map these things. And the original templates we did for HL7v2 were based on the work that was already being done by the 2 to FHIR working groups to say, you've already defined the mappings from HL7v2 to FHIR. So now let's go to do the same thing with CDA documents and create some of those things. So what did this result in is the question. We did this work, we quickly jumped in and said, okay, let's go build a bunch of templates. Let's make sure the engine can handle CCD to FHIR transformation. What happens now? So things got very exciting. So what we ended up having then was a Power App that we published that enabled labs, so up in the upper left-hand corner, enabled labs to easily report, and it would just send FHIR resources to a FHIR API, and we would put that into our FHIR server. So that was just native FHIR through a Power App where they could do self-reporting right into the FHIR API. For the emergency departments around the city, they were still outputting their CCDs, and those were actually the process they were already using that was already in place that we didn't touch was they were uploading those into an FTP folder, secure FTP folder. So we didn't touch that process. We let them continue to do that, but then we would just pull them out of that FTP folder and run them through the FHIR Converter, doing the CCD to FHIR conversion. And that would turn those CCDs into FHIR bundles, and then we would push those through the same FHIR API and into the same data store as where the lab results were coming from. So now the Department of Public Health was getting relative real-time data, not only from the labs, but also from the emergency departments. And all of that data was coming together into a common data store in FHIR format. And now they could start to build some reporting on it. So we had tools, we have tools like our Power BI connector, so they could start creating visualizations, maps, and things like that. But they could also build apps and reporting systems to report to the CDC and look at how to respond to what was happening in their city. I'm not going to necessarily claim that we are the cause of this, but if you look at the COVID data for the city, and I didn't grab the chart, but basically the confirmed cases of COVID were on the rise into April when this happened. And over the next month or two, they started to drop down. And one could argue maybe awareness and knowing where things were happening and all that gave the city the opportunity to respond more effectively and know what to do. Or it could just be that we all got smarter about the pandemic and we knew how to respond and how to react to it. But it did put the city and the Department of Public Health in a good position to collect data and report that data much more easily. So this was just a story that I want to share for how FHIR played a role in helping address the pandemic in a major US city, and how we were able to help by converting data from what we often think of as a legacy format, in this case, CCD, into FHIR bundles that can then be used in more meaningful ways. It's a rapid fire short community session. We only have 15 minutes, but we do have about 5 minutes for Q&A. So I want to open it up. And if you see questions coming in, please let me know. Or if there's questions that you have, please feel free to ask.
I do see a question. It says, do you store the transformed resources as a separate resource or in the context of a bundle? Oh,
excellent question. So the way the FHIR API works is the bundle comes in, but then we ultimately store the resources independently. So every FHIR resource that comes in is stored as an independent resource and indexed appropriately. So then it becomes searchable on that. So the bundle is more of just a container for getting the FHIR resources in, and then they become independent FHIR resources in the API.
And that's the only one we have in the Whova chat or the Whova Q&A.
Feel free, Victoria, to open up the mics and let people ask questions. We have 2 or 3 minutes left if we want.
This is Gay Dolan. Can you hear me?
Yes.
So if you separate the resources out, or you separate, you've transformed from the CDA CCD template, the resource that goes in a bundle. Mm-hmm. Often there is data in the header of a CCD that is not immediately present in the entry, and so it could be lost data. Like you might have the author or the performer or whatever that, because of context conduction, is not reiterated down in the entry, and that's not the case with FHIR. So how do you handle that if you then store them separately?
I'd have to go back and look and see what we did there. We do have, for our CCD conversion, we do have essentially a header conversion template or sub-template as part of that to capture some of that information. But I'd have to actually go back and look and see specifically what we did there. There are cases, and we've run into this in different scenarios, whether it's HL7v2 or CDA documents, is that any transformation has the potential to be a lossy transformation. And so in all of these cases, we tend to work with whoever's doing the process, the workloads, to understand what the potential for lossiness is and to understand whether that's an acceptable thing or not. We can always throw the original CCD documents into a storage container for reference at a later point. But specifically, I'd have to go back and look and see what we did there, but we do have some ability to capture that data in some way.
Well, it's a thorny topic, and there is a project starting up at HL7 to kind of deal with those different challenges in this transform.
Yeah, and actually some of the work we've done to do some of these transforms, it's kind of a interesting cycle or cyclical effect in that when we started, the very first thing we did was got involved with the FHIR community or working group that was going on to kind of leverage the brain power that was already there to say, okay, if you already understand the HL7v2 to FHIR mapping, let's just harness that, let's use that, let's not create something new. And so all of our templates were based on that work. And then as we started to do the CDA to FHIR transformation, it kind of came back where then there was interest from folks in various HL7 working groups of, hey, that's interesting. How'd you do that? What'd you do? Maybe we can do some other applications there. We're seeing the same thing with, we have a feature in our DICOM service called DICOM Cast, which will project metadata from a DICOM instance into a FHIR service. And so we're looking at that as is there a potential to define a standard for how DICOM metadata maps to FHIR in the correct way?
Okay, thanks. Well, come and join and contribute your experience.
Absolutely, we'd love to.
We do have one more question in
Yeah.
the Q&A. Have other jurisdictions or partners adopted this solution?
So this particular solution, I don't know that it was never packaged up for broad use as much as it was something that helped us evolve our technology that then can be applied to lots of other places. We do have quite a number of customers and partners using our converter, both as an open source project, and we've also started to build it into our managed FHIR service. So there's lots of customers using it for different ways, but this particular solution was never really packaged as reusable as much as it's more of a case study of what you can do.
Well, thank you so much. I think we are actually out of time, but thank you so much, Doug. And thank you everyone for attending. And don't forget to rate the session in Uva.
My pleasure. Thank you, everybody.